Good evening. Last class we solved some problems. Today we are solving some more problems. Let us consider one IIT problem. Now, the problem is a function f. F is a function from R to R, from real number set to real number set. That function satisfies the condition f of x plus y is equal to f of x, f of y. The function satisfies the condition f of x plus y is equal to f of x, f of y. For all xy belonging to R, and fx is not equal to 0 for any x in R. That is, very important condition is fx is not equal to 0 for any x means for all x in R. The function is differentiable. We are making use of this condition. We are making use of this condition. Fx is not equal to 0. We are using this condition. The function is differentiable. We are also using this condition. At the same time, f dash 0 is 2. We are also using this condition. F dash 0 is 2. Show that f dash x is equal to 2 times fx for all x in R. Hence, find f of x. Ultimately, our aim is to find the function. Our aim is to find the function. I repeat again. A function from real number to real number set satisfies condition number 1. F of x plus y is equal to f of x, f of y. F of x not equal to 0. Second condition. The function is differentiable. Third condition. F dash 0 is equal to 2. That is the fourth condition. And f dash, we are showing that with these four conditions, we are showing f dash x is 2 times fx, and ultimately we are finding fx. Using condition 1, 2, 3, 4, we are proving this. At the same time, we are finding the function f of x. Let us see how this is obtained. It's very simple. F of x plus y is equal to f of x into f of y. This is given. This is the given condition. Understand carefully right from the beginning. That's very important. Concentration is very important. In mathematics, we require concentration. F of x plus y is f of x, f of y given. Condition is given. It is true for all x and y. In particular, we are making y 0. In this, we are making y 0. F of x plus 0 is f of x, f of 0. F of x plus 0 is f of x. Because x, y are real numbers, x plus 0 is x. 0 is the additivity for real numbers under addition. F of x plus 0 is f of x, f of x, f of 0. And ultimately, this fx is not equal to 0. Suppose if you have 7x is equal to 8x, we cannot cancel 7 into 0, sorry. If you have 7 into 0 is equal to 8 into 0, we cannot cancel 0, 0 and say 7 is equal to 8. We can cancel a quantity which cannot take the value 0, which cannot. So here fx is not equal to 0. Fx is not equal to 0. That's why we are cancelling fx. We are cancelling fx. So therefore, that gives f0 is equal to 1. f0 is equal to 1 since fx is not equal to 0. Since fx is not equal to 0, we are cancelling f of x, and ultimately f0 is 1. So we are getting one condition, namely f0 is equal to 1. f0 is equal to 1. One important condition we are obtaining. Now, once f0 is 1, we are making use of differentiability, condition of differentiability. Function is differentiable. Therefore, f dash 0, limit h tends to 0, f of 0 plus h minus f0 by h. F dash x is f of x plus h minus fx by h. F dash 0 is limit h tends to 0, f of 0 plus h minus f0 by h. Now, f dash 0, this is the definition of f dash 0 by continuity and limit definition, differentiable condition. F dash 0 is limit h tends to 0, f of 0 plus h minus f0 by h. F of 0 plus h is fh. F0 is 1. Just now we have proved f0 is 1. F0 is 1. In the previous step, we have put f0 is 1. Therefore, fh minus 1 by it is given that f dash 0 is 2. I am applying the definition of f dash 0 using the definition, limit definition of f dash 0. We get 2 is equal to limit h tends to 0 fh minus 1 by h. This is another condition we are getting. We call these as 1. Okay. We are also using the definition of f dash x. It is given that f dash fx is differentiable function. Every differential function satisfies this condition. F dash x exists and it is unique. Limit h tends to 0 f of x plus h minus fx by h. This is the definition of f dash x. From this, f dash 0 is written here. F dash x is written here. Limit h tends to 0. F of x plus y is f of x, f of y. I am using that condition. F of x plus h is f of x, f of h minus f of x by h. Fx is common. In these two terms, fx is common. That is independent of h. Therefore, that is taken out. That is taken out. Fx limit h tends to 0, fh minus 1 by h. Fh minus 1 by h limit h tends to 0 is 2. Therefore, this is replaced by 2. Therefore, we are getting f dash x is equal to 2 times fx. F dash x is equal to 2 times fx. So, this is what we require. F dash x is equal to 2 times f of x. That is first result we require. Second result is find f of x. Second result is find. I repeat again. This is from the definition. Fx is differentiable at all x. Therefore, I am writing f dash x 0 and f dash x. Using f dash 0 is 2. Therefore, we get this. Because f0 is 1, we have obtained. F dash x is this one. Here, I am using the definition f of x plus y is f of x into f of y. Using that, we get this. Again, f of x can be taken out because this limit is only for h, not for x. Therefore, f of x is taken out. This is obtained as 2. It is obtained as 2. So, therefore, f dash x is equal to 2 times f of x. We have proved f dash x is equal to 2 times f of x. That is another result to be proved. Okay. Next, the problem is not over. Therefore, f dash x is equal to 2 times f of x. 2 times fx. F dash x by fx is equal to 2. I am bringing fx to the denominator. And now in integral, there is one formula. We know integral 1 by x is log x. Log x plus some constant. If numerator is differentiation of denominator, the integral is log of denominator. That is, in general, f dash x by fx. In the integrand, if you have f dash x by fx, you get log of f of x. You get log of f of x. So here, we are having f dash x by fx. Integrating both sides, you get log of denominator because differentiating log fx, 1 by fx, f dash x. Integrating this, we get this. Integrating 2 into 1, you get 2x plus some constant. This result is true for all x. In particular, when x is equal to 0, log of f0 is 0 plus c. f0 is 1 given. f0 is 1 given. Therefore, log f0 is 0 plus c. f0 is 1. Therefore, log 1 is 0. Log 1 is 0, that is equal to c. Therefore, we are getting the value of c. We are giving x is equal to 0 only to find the value of c, which happens to be 0. So, we have obtained c is equal to 0. I repeat again, f dash x is 2 times fx, divide by fx, f dash x by fx is 2, integrating with respect to x, we get log of f of x. When the integrand is numerator is differentiation of denominator, then integral is log of denominator. Integrating 1, you get x, therefore 2x plus c. Put x is equal to 0 to find the value of c. f0 we are getting, f0 is 1, log 1 is 0, therefore c happens to be 0. So to find the value of c, we are giving x is equal to 0. So we obtained c, and that c is nothing but turns out to be 0. c is 0. Once c is 0, log fx is 2x plus c. c is 0 we are making. Fx, we know the definition of logarithm, log a to the base b is equal to c. Therefore, a is equal to b power c. The base is raised in order to equal a. So, logarithm of a number to a given base is the index of the power to which base is raised in order to equal the number. So applying the definition of logarithm, you get a is equal to b power c. Fx is equal to e power 2x. So we have obtained the function as fx is equal to e power 2x. Now, if you want to get verified, our answer is correct because f of x plus y, if you find, that becomes e power 2 times x plus y, which is nothing but e power 2x into e power 2y. E power 2x is fx, e power 2y is fy, fx into fy. So f of x plus y is fx fy. So it's verified. So this is the correct answer. So it's a very interesting, important problem. We are using all the conditions, function f of x plus y is f of x, f of y, f of x not equal to 0 to cancel f of x. Differentiability condition we are using that we are writing f dash x, we are also writing f dash x, and ultimately we are proving this equal to this. Using this integration, we get the value, we get the function fx as e power 2x. We are getting fx as e power 2x. So this is the problem. Very interesting, important problem. Almost all conditions under differentiation are used. That's why it is considered to be very, very, very important problem. Okay. Next problem. Tan inverse 4x by 1 plus by x square plus tan inverse 2 plus 3x by 3 minus 2x. Find it dy by dx. Now, we are having inverse function. Whenever inverse functions are used, whenever inverse functions are present, we try to reduce it to a simple function. We try to reduce it to a simple function. Some 2-3 examples I given. This is one example. Now, in this problem, we are converting this as tan inverse a plus b by 1 minus ab, or tan inverse a plus b by 1 minus ab. So, if you have this formula, tan inverse a plus tan inverse b is nothing but tan inverse a plus b by 1 minus ab. 1 minus ab. So, if we have tan inverse a plus b by 1 minus ab, we are separating this. While separating, what happens? One may be constant, either these or these will be constant. You can differentiate other function. Similarly, we can also use the formula tan inverse a minus tan inverse b is equal to tan inverse a minus b by 1 plus ab. So, either this formula or this formula can be used to reduce this to a simple function. Let us see how it is reduced. Now, I am writing 4x as 5x minus x, 5x square as 5x into x. I am writing 4x as 5x minus x. And in the next term, 3 is taken out from the numerator and denominator, 2 by 3x, 1 minus 2 by 3x, so that 3 gets cancelled. Why so? Because this is in the form tan inverse a minus b by 1 plus ab. A minus b by 1 plus a. A is 5x, b is x. This is the form tan inverse a plus b by 1 plus ab. By 1 a plus b by 1 minus ab. So therefore, this is in the form tan inverse 5x minus tan inverse x. This is in the form tan inverse 2 by 3 plus tan inverse x. Because we are having a plus b here, you get a minus b here. Now, our differential coefficient becomes very, very easy because this is a constant. So, differentiating tan inverse 5x, we get 1 by 1 plus. And this tan inverse x also gets cancelled. Only one term we have to differentiate. So, instead of 2 terms, big terms, we are differentiating only one term. Differentiating tan inverse 5x using function of a function rule. If you differentiate tan inverse x, you get 1 by 1 plus x square. 1 by 1 plus x square, where x is the argument. If you have tan inverse 5x is the argument for this function. Therefore, 1 by 1 plus 5x whole square, that is 20x square. Differentiate 5x, you get 5. So, therefore, ultimately you get 5 by 1 plus 25x square. I repeat again, differentiating tan inverse x, you get 1 by 1 plus x square, where x is argument. If argument is 5x, you get 5x whole square, that is 25x square. Different version of 5x, you get 5. So, that is 5 by 1 plus 25x square. We are getting this. Tan inverse x gets cancelled, tan inverse 2 by 3 is a constant, so we are differentiating only one term, which is very easy for us, So that's why we are converting this to the form tan inverse a minus b by 1 plus ab. We are converting these as tan inverse a plus b by 1 minus ab. Ultimately, we are getting only one term that can be differentiated easily. See here, they will give the answer. They will give 4 answers. You have to choose one correct answer. Sometimes 2 correct answers will be there, 3 correct answers will be there. I told you already. In section A, 4 answers will be given, only 1 is correct. Section B, 4 answers will be given, either 1 may be correct, or 2 may be correct, or 3 may be correct, all 4 may be correct. So therefore, in section B, definitely you will be committing a mistake. Here, 20 questions will be asked, 5 questions will be asked, and the remaining 5 questions, section C, all integer type. So only integer answer. Answer will be 1, 2, 3, minus 1, minus 2, like that. Only integer answer. If you get 1 by 2, you can delete that answer. So integer type of answer you can expect in C. Section B, 1 correct answer, 2 correct answers, 3 correct answers, all 4 are correct. Section A, only 1 is correct. So therefore, section B and C, using section B and section C, you can overtake 1 lakh students. So therefore, concentrate on B and C, you can get more marks. Section A will be easy. Automatically with this preparation, you can answer section A. Now consider this problem. This problem, in fact, directly you can differentiate. It requires a lot of simplification. You may not get the correct answer. The ultimate answer will be 1 by 2, 1 by 17, something like that. So if that is the case, you cannot simplify to that extent. For that, whenever inverse functions are involved, you must reduce it to the simplest inverse function. What we do is cos inverse 1 by root 17 cos x plus 4 by root 17 sin x. 4 by root 17 sin x. Now this is, you can convert this to the form cos inverse cos a minus b or cos inverse cos a plus b. For that, you can replace this by cos alpha. We can replace this by cos beta. Cos alpha, cos beta. How is that possible? For that, we are using this methodology. Now see here. You take cos x plus 4 sin x. Multiply by root 17 and divide by root 17. Multiply by root 17 and divide by root 17. So root 17. This is in the form 1 by root 17 cos x, 4 by root 17 sin x. Suppose cos x, suppose if you take a triangle, in which the sides are 1 and 4, this will be root of 17, root of 16 plus 1, root 17. If you take this as alpha, then cos alpha will be 1 by root 17. This is replaced by cos alpha. And sin alpha will be 4 by root 17. So therefore, this is replaced by sin alpha. This is replaced by cos alpha. Therefore, I'll do it separately like this. And okay, you can directly follow. 1 by root 17 cos alpha, 4 by root 17 sin alpha. Therefore, we get cos alpha cos x, sin alpha sin x, cos x minus alpha. Cos a minus b is cos a cos b plus sin a sin b. So therefore, we are replacing 1 by root 17 by cos alpha, and 4 by root 17 by sin alpha. 4 by root 17 by sin alpha. So therefore, automatically cos inverse x minus alpha, where alpha is nothing but tan alpha is 4 by root 17. Therefore, automatically alpha is nothing but tan inverse 4 by root 17. So tan inverse 4 by 1. Sorry. Because tan alpha is 4 by 1. Therefore, alpha is tan inverse 4 by 1. So therefore, this cos x minus alpha, where alpha is tan inverse 4, or you can retain this as alpha, where alpha is fixed. Alpha is a constant. This is our constant. So therefore, we are getting root 17 cos x minus alpha. Y is equal to cos inverse root 17 by root 17 cos of x minus this. So automatically root 17 gets cancelled, and cos inverse cos theta is theta. applying the property, you get x minus tan inverse 4. So y is equal to x minus tan inverse 4. Therefore, dy by dx is equal to 1. This problem can be asked under integer type. This can be asked under section C. Section C, integer type. Dy by dx is 1, 2, 3, 4. Which is the correct answer. We are getting dy by dx is 1. I repeat again. We are replacing 1 by root 17 by cos alpha, 4 by root 17 by sin alpha from this triangle. From this triangle, cos alpha is 1 by root 17, sin alpha is 4 by root 17. Cos alpha, cos x, sin alpha, sin x, cos a minus b, that is cos x minus alpha. Alpha is, tan alpha is 4, therefore alpha is tan inverse 4. Alpha is replaced by tan inverse 4. So we are getting cos inverse cos theta, that is theta. We get x minus tan inverse 4. Dy by dx is 1. Hope it is clear. So this is a very simple problem. It's a very simple problem. Once you have this kind of problem, try to convert this into simple function. Cos inverse cos theta, cos inverse sin inverse sin theta, like that. Automatically we can get a simple function. Dy by dx can be obtained. This can be asked under integer type because we are getting dy by dx as 1. Okay. This is one important problem. Usually in IIT and all other competitive examination, the very same problem will be asked, giving some values to P and the Q. P4, Q5, P plus Q, 4 plus 5, 9. They can give like that. Or P can be replaced by A, Q can be replaced by B, P plus Q is A plus B, like that. Once this function is given, show that dy by dx is equal to x by y, y by x, 2y, 2x, something like that. So whenever this is nothing but an implicit function, this is nothing but implicit function because y is not given in terms of x, y is not given in terms of x. We have to find a dy by dx. So x power p y power q, x power p y power q is equal to x plus y power p plus q. X plus y power p plus q. So therefore, x power p y power q is x plus y power p plus q. You take logarithm, that is easiest for us. Taking logarithm, we are having product, therefore p log x plus logarithm of y power q, q log y. I am using two properties at a time, that is logarithm of product is sum of the logarithms. At the same time, power can be taken outside the logarithm. And here, p plus q log x plus y. P plus q log x plus y. So, taking logarithm, p log x plus q log y is equal to p plus q log x plus y. Now, we are ready to differentiate. We are ready to differentiate. Differentiating p log x, p by x. Differentiating q log y, 1 by y, dy by dx. Because differentiating log y equal to 1 by y, dy by dx. Log fx, 1 by fx, f dash x, like that. P plus q, differentiating log x plus y, 1 over x plus y. I am writing x plus y in the denominator. Into differentiation of x plus y, that gives 1 plus dy by dx. That is 1 plus dy by dx. Understand this step? P log x plus q log y is equal to p plus q log x plus y. P by x plus q by y divided by dx is equal to p plus q by x plus y into differentiation of x plus y is 1 plus dy by dx. I am grouping the terms containing dy by dx. So, grouping the terms containing dy by dx. Q by y here, left hand side q by y, right hand side p plus q by x plus y into dy by dx, therefore minus of p plus q by x plus y by bringing this term to left hand side. Right hand side p plus q by x plus y into 1, p plus q by x plus y into 1. This is free from dy by dx, minus p by x. Minus p by x. This problem can be solved even if you have some numbers p as 4, q as 5. Directly we can do it. X power 4, 4 log x, like that. It's very easy. Only thing is p and q are the numbers. Now you simplify the brackets. Now. We are simplifying these bracket functions inside the bracket. Yes. Now dy by dx times taking y into x plus y as LCM in the left hand side, qx plus qy. You get qx plus qy, y times p plus q. So minus py minus qy is equal to, in the right hand side, x into x plus y is taken as LCM. We get px plus qy minus, or px plus qx minus px minus py. Okay, so now here qy gets cancelled, here px gets cancelled, here x plus y gets cancelled with this x plus y. Now, okay, now we are nearing the answer. Qx minus py, we are left with the qx minus py. So dy by dx times qx minus py by y. Here also qx minus py by x. And qx minus py gets cancelled. Dy by dx by y is equal to 1 by x. Therefore, dy by dx is equal to y by x. So the answer is dy by dx is y. So very simple problem. Very simple problem. So we can easily get the answer y by x. Okay. Next problem. Y is equal to x times log x by a plus bx. Show that x cubed d square y by dx square is x dy by dx minus y whole square. We are simplifying left hand side, we are simplifying right hand side, so that they are equal. That's the only way. Directly reducing this from this or this from that is a bit difficult. Directly you can take left hand side separately, right hand separately, do it. We will follow the procedure. Okay. Y is equal to x log x by a plus bx. It involves some simplification. Mere simplification, nothing else. Applying the properties of logarithm. Y is equal to x log x minus x log a plus bx, because applying log a by b is log a minus log b. X times log x minus log a plus bx. Log x minus log a plus bx. Bring x inside. You are getting the next step. So therefore, x log x minus x log a plus bx. Apply log a by b is log a minus log b. Bringing x inside. Now differentiate. X times 1 over x. Differentiating log x using x log x using product rule. X times 1 by x plus log x into 1. We get automatically 1 plus log x. Here again using product rule. Minus x into differentiating log a plus bx 1 by a plus bx into b minus xb by a plus bx minus log a plus bx differentiating x, we get 1. We can group 1 under xb by a plus bx. 1 and xb, 1 minus xb by a plus bx. You take LCM, a plus bx minus bx gets cancelled. 1 by, you get 1 over. We can easily get a is there, a plus bx, a by a plus bx. These using grouping these two gives us this term. So log x remains as it is, minus log a plus bx as it is. These two terms, 1 minus xb by a plus bx gives us a by a plus bx. Now we see from the given result, using the given result, that is given function. The given function log x by a plus bx is y by x, because if you get y by x from this, is nothing but log of x by a plus bx. Y by x is log of x. So wherever you get log of x plus a by a plus bx, that can be replaced by a by x because it's a simple expression. So therefore, what will be is log of x minus log of a plus bx is log x by a plus bx. That is replaced by y by x. These two we are reducing to y by x, a by a plus bx using the given function. So multiply by x, you get x divided by x minus y, bring that y that side, ax by a plus bx. So we are getting result number 2. X divided by x minus y, it is required in the answer. That's why we are getting x divided by x minus y, ax by a plus bx. Once you get x divided by x minus y as ax by a plus bx, we can make use of this result for higher order derivatives using product rule. X divided by dx, differentiating x into d square by dx square, differentiating divided by x equal to d square by dx square, plus divided by x into 1, and here minus sign, you get minus sign, minus differentiating y, you get divided by x, and here using quotient rule, if you differentiate this, denominator square, denominator distribution of numerator minus numerator distribution of denominator, that gives a square by a plus bx whole square. I repeat again, using product rule, x d square by x square plus divided by x into 1 minus y, differentiating y, you get divided by x. Using quotient rule, differentiate, you get this. Differentiating this, you get this. Multiply by x. These two gets cancelled. X square, d square by x square. Multiply by x cube. I think we want a square. Multiply by x square. Okay, a square, x square. I think multiply by x only correct. I think let us see. Very fine. So if you multiply by x, you get this. If you multiply by this by x, you get a square x. And if you multiply by x only. So I think you get a square x. Please verify that. So you get a square x square by a plus bx. Please verify that expression. And x square discovered x square is equal to a square x square by ba plus bx whole square. And x divided by x minus y whole square is a square x square by a plus bx whole square. Therefore, these two coincide. This coincides exactly with this. So therefore, automatically we come to a conclusion. We get see the answer. X cube discovered by x square. For that, to get x cubed discovered by x square, multiply by x square, you get x cubed discovered by x square. Here you get s square x square. I repeat again, we are getting this step. This is negative. This 2 gets cancelled. You multiply this by x square, you get x cubed here. You multiply this by x square, you get s square x square by a plus bx whole square. But ax by a plus bx is x divided by x minus y. Squaring x divided by x minus y whole square is a square x square by a plus b whole square. Exactly this term. Therefore, x cubed square by x square is equal to this. This is what we require. So it's juggling. We adjust the terms to get the answer. That's all. It's a very simple problem. It's a very, very important problem. It is an IIT problem. See, first of all, we'll analyze the problem. How to analyze the problem? That is, x is less than 1. What for it is given? So, whenever some condition is given, necessarily we have to make use of that condition. X is less than 1. 1 minus 2x by 1 minus x plus x square plus 2x minus 4x cubed by 1 minus x square plus 4x cubed. 4x cubed minus 8x power 7 by 1 minus x power 4 plus x power 8, etc. up to infinity. We are going up to infinity. That is equal to 1 plus 2x by 1 plus x plus x square. This somewhat a bit difficult problem. It requires a lot of explanation. Now, we start with some algebraic expressions. We start with the algebraic expressions. You get one particular equation, take logarithm, differentiate, automatically you can see the answer. Okay. What we do for that? Understand carefully. I am considering the product 1 minus x plus x square, 1 plus x plus x square. 1 plus x square, 1 plus x square, plus x minus x. Therefore, this is nothing but 1 plus x square whole square minus x square. So 1 minus x plus x square, 1 plus x plus x square is a minus b, a plus b, a square minus b square. A is 1 plus x square, 2 plus x square whole square minus x square. This ultimately gives us 1 plus x power 4, 2x square minus x square, x square. So this product gives us exactly this one. You delete this term. This is wrongly typed. This is wrongly typed. This product exactly gives us this. See that? You understand this step? 1 minus x plus x square, 1 plus x plus x square. That product, it is in the form a plus x, a minus x, where a is 1 plus x square. That gives ultimately 1 plus x square plus x power 4. That's all. You take one more term. With this product, we attach one more. 1 minus x square plus x power 4 we attach this factor. That is, we are finding the product of these two now. This product gives this. We are extending this factor. Therefore, we are finding. Again, it is in the form a plus x, a minus x. A is 1 plus x power 4. B is x square. See, the product gives us 1 plus x power 4 plus x power 8. Now, you consider 1 plus x plus x square, 1 minus x plus x square, 1 minus x square plus x power 4. You attach this as 1 minus x square x. These three, along with these three, we are attaching 1 minus x power 4 x power 8. Like that, we are extending every time we attach 1 minus x square x power 4. Next time, 1 minus x power 4 x power 8. Like that, every time we are adding that. We get ultimately, if you do this operation by attaching one factor, two factors, three factors like that, you attach this factor, ultimately, you attach this factor. Ultimately, we get 1 plus x power 2 power n plus x power 2 power n plus 1. 2 power n plus 1. When n is equal to 1, 2 power 1. N is equal to 1, we get 1 plus 1. 2 square is 4. So this, when n is equal to 1, gives this. When n is equal to 2, gives this. Ultimately, when n is equal to n, we get the last factor that you get in the right hand side. Therefore, the product of 1 plus x square, 1 minus x plus x square, 1 minus x square plus x power 4, 1 minus x power 4 plus x power 8, etc. n factors gives us this. Gives us this. Just understand. That will do. Once you get this, what happens as n tends to infinity? What happens as n tends to infinity? As n tends to infinity means, we all know a number, you take a number less than 1, half. Half power 1 gives 0.5. Half power 2 gives 0.25 because 1 by 4. Half power 3, 0.125. Number goes on decreasing. Small. Half power infinity, very zero, very small, that is 0. Therefore, this x is less than 1, power a big number. When x is like half, 1 by 3, 1 by 6, 1 by 7, like that. When this number is less than 1, that is given at the beginning, x power 2 power n as n tends to infinity becomes 0. This becomes 0, this becomes 0. Therefore, ultimately, we are getting up to infinity. 1 minus x plus x square, 1 plus x plus x square, 1 minus x power 4, like that. We are going up to infinity. So, therefore, this product as n tends to infinity. Right hand side, we are getting 1. Because this term becomes 0, this term becomes 0, we are getting 1. So, therefore, right hand side becomes 1. We are having 1 plus x square, 1 minus x plus x square into like that. 1 minus x square x power 4, 1 minus x power 4 x power 8, like that it goes. It is enough you remember this. To get the answer for this problem, it is enough you get this expression. Once you get this product is equal to 1, take logarithm. It's a very interesting problem. Taking logarithm of product, sum of the logarithms. Log ABC, log A plus log B plus log C. Applying that formula. Log of first factor, 1 plus x square. Plus log of second factor, 1 minus x plus x square. Plus log of third factor, 1 minus x square plus x power 4. Plus etc. Right hand side, log 1, 0. Therefore, sum is equal to 0. Now we differentiate term by term. If we differentiate this term, 1 over 1 plus x square, differentiating x plus x square, 1 plus 2x. Function. Log of fx, 1 by fx, f dash x. Log of differentiating this, 1 minus x plus x square into 2x minus 1, etc. What you do is, you retain this as it is, you bring all other terms to other side. You retain 1 plus 2x by 1 plus x square as it is. You bring all the terms to other side. 2x minus 1, bring it to other side, we get 1 minus 2x. 2x minus 1 becomes 1 minus x. 1 minus 2x by 1 minus x square. Next term becomes 4x cubed minus 2x becomes 2x minus 4x cubed by 1 minus x square x square. Like that. So therefore, this up to infinity is equal to 1 plus 2x by 1 plus x square. It's a very simple, interesting problem. It involves this concept, multiplying continuously with the factor, the particular factor, so that we are getting one more factor. We using including negative side the middle factor, middle term. Like that, ultimately we get we go up to infinity. Automatically, right hand side becomes 1. Take logarithm, differentiate, bring this term, that is except first term, bring all the terms on the other side. We are seeing the answer. This is a very interesting, simple problem. Okay. Now, how to differentiate a determinant? It's very, very important. Again, it's an important problem for competitive examination. How to differentiate a determinant? Please listen, understand the concept. If you want, I'll explain with an example first. After that, we'll come to this problem. Okay. Suppose our function is in the form of a determinant. X square 2, 3x. In fact, we can differentiate. This is a 2 by 2 determinant, easy for us. 3x square minus 2x square. 3x square minus 2x square x square. F dash x is 2x. Very easy. Problem over. Whereas, to differentiate a determinant, you expand determinant, differentiate. Easy way. Whereas, if you have 4 by 4 determinant, 5 by 5 determinant, 3 by 3 determinant, and so on, how to differentiate? Now, the same f dash x to x can be obtained in a different way. Now, see here, to differentiate a determinant, we write 2 determinants. If you have 2 by 2 determinant, in the first determinant, you differentiate first row alone, the elements in the first row, keeping others as it is. In the second determinant, keep first as it is, differentiate second alone. Expand. Now, 3x minus 4x minus x plus 3x. You get 2x. Same f dash x. Therefore, what's the rule? The rule is to differentiate determinant, 2 by 2 determinant, you get 2 determinants. In the first determinant, differentiate only elements in the first row. Differentiate determinant only in the first row. That is x square, x1, x square, 2x. Plus, keep other second row as it is. In the second determinant, keep first row as it is, differentiate the elements in the second determinant, differentiating 2, 0, differentiating 3x. Expand this, you get same answer. This methodology can be followed to differentiate a determinant of order 2, order 3, order 4, order 5, any order of any order. Now, coming back to this problem, we are having a determinant of order 3. So, to differentiate this, in the first determinant, we prepare 3 determinants because it's a determinant of order 3. In the first determinant, differentiate elements in the first row alone. 1, 2x, 3x square. Keep other things as it is. 1 plus 2x plus 3x square. 0, 2, 6x. In the second determinant, keep first row as it is. Differentiate elements in the second row alone. 0, 2, 6x. 0, 2, 6x. The third determinant, keep first 2 rows as it is. Differentiate elements in the third row. 0, 0, 6. 0, 0. Now, this determinant is 0 because first 2 rows are identical. 0. Here last 2 rows are identical. 0. It is enough you expand this and get answer. You can expand using any row or any column. So, f dash x is nothing but, for understanding, I am interchanging first row and the third row. One negative sign, you get one negative sign out. 0, 0, 6, 1, 2x, 3x square, x square, x cube. I am interchanging first row with third row because we can expand with the help of first row. 2 elements are 0, easy for us to expand. So, therefore, we are getting 0 into anything 0, 0 into anything 0, minus 6 into minus sign is out. By interchanging 2 rows, the determinant changes its sign, therefore, minus sign is taken out. Minus 6 times x square minus 2x square. You get x square minus 2x square minus x square. That is 6x square is the answer. So, therefore, for fx, determinant x square, x cube, 1, 2x, 3x square, 0, 2, 6x. F dash x is nothing but 6x square. If you want, you can expand the determinant. You get a cubic third degree expression. Differentiate term by term. See that ultimately we get 6x square. See that ultimately we get 6 square. Therefore, what's the methodology used? The methodology is to differentiate determinant of third order. We write 3 determinants. In the first determinant, to differentiate elements in the first row alone, keeping other 2 rows as it is. In the second determinant, keep first row and third row as it is. Differentiate determinant in the elements in the second row alone. In the third determinant, keep first row and second row as it is. Differentiate elements in the third row alone. We get expand all the 3 determinants. That gives f dash x. That gives correct f dash x. Here, first 2 determinants are 0 because we are getting 2 rows are identical. In the last determinant 0, 0, 0, I am bringing to the first row for convenience sake. After that, expanding, you get 6 into minus 6 into x square minus. There is expanding using first row, 0 into anything 0, 0 into anything 0, minus 0 into anything 0, 6 into this. So this gives x square minus 2x square minus x square. Therefore, plus 6x square is the answer. So therefore, any determinant can be expanded by this methodology. Yes, 6 into 2x square minus x square, x square. 6x square is the answer. So the correct answer is 6x square. Well, we have omitted 6. Okay. Another IIT problem. Another IIT problem. G is the inverse function of f. F dash x is 1 by 1 plus x power. See the methodology here. These are not direct problems; they are indirect problems. They are indirect problems, but you must know how to solve problems of this kind. That's very, very important. G is the inverse function of f. G is the inverse function of f. G is the inverse function of f. Or f inverse is G. Gx. G means Gx. Gx is inverse function of x. Gx is f dash x. It is given that f dash x is 1 by 1 plus x power n. Prove that g dash x is 1 plus gx power n. See, it's a problem involving only functions, nothing else. A direct function is not given. Fx is log x, fx is e power x, fx is sin x. It is not given like that. G, only condition is G is the inverse of f. Gx is equal to f inverse x. Now, it's very, very simple problem. Gx is f inverse x. From this definition of inverse function, f of g of x is x. From this, f of g of x is equal to x. F inverse is g. F of g of x is x. F of g of x is x. Now we are differentiating this function. How will you differentiate f of g of x? Function of a function rule. First f dash x. F dash. You differentiate along with the argument. Argument is gx. I am writing f dash g of x. Differentiate along with the argument f dash g of x. Differentiate g of x, you get g dash x. Differentiate g of x, you get j dash x. Differentiating x, we get 1. F dash g of x, g dash x is equal to 1. From this, g dash x is equal to 1 over f dash gx. 1 over f dash gx. It is given that f dash x is 1 by, see that condition as f dash x is 1 by 1 plus x power n. If you have x here, you get x power n. 1 by 1 plus x power n. Accordingly, f dash x, if you have, instead of x, we are having gx, you get 1 by 1 plus. So 1 by 1 plus, since we are having 1 over f dash x, 1 over f dash x is 1 by 1 plus gx power n. This one I have written here. This f dash x is nothing but 1 by 1 plus g of x power n, because we are having gx here. Because 1 over 1 by x is x. Therefore, 1 by 1 by x is x. Is 1 plus gx power n. So g dash x is 1 plus gx power n. So very simple problem. Very simple. Once you know, it's very simple. Once you know this, the methodology of solving the problem is known. The problem becomes very, very simple. Until such time, it is difficult. I repeat again, gx is f inverse x. F of g of x is x. From the definition of inverse function, f of g of x is x. Differentiating f dash g of x, G of x again differentiating with g dash x is equal to 1 because right hand side x 1. G dash x is 1 over f dash g of x. F dash x definition we are using. F dash x is 1 by 1 plus x power n. Here the denominator f dash g of x is 1 by 1 plus gx power n. 4 by 1 by 1 by 5 is 5. Therefore, you get 1 plus gx power n goes to the numerator, 1 plus gx power n. Therefore, g dash x is 1 plus gx power n. Now, you can ask one question. Can you give some function at random and verify this? Yes. You must give proper function satisfying the given condition. That condition is f dash x is 1 by 1 plus x power n. That condition must be satisfied. You can choose one function satisfying the condition, automatically we can verify g dash x is 1 plus x power n. So therefore everything depends on choosing the function. Everything depends on how you choose the function. Here without knowing the function, without knowing what is gx, what is g dash x, what is fx, what is f dash x, you can directly get the answer to the problem. So therefore, whenever you have one function is the inverse function of the other, apply the definition of inverse function. You can easily see that the answer is obtained directly. Now, today we have covered only few slides. We can stop with this slide number 62. Next class we can complete. This is the extra class only. Okay, next class we can complete the differentiation by solving some more problems given in the following slides, and after that we can go to important near integration or probability or any chapter. Once if it is ready, if it is typed, we can start the chapter. Okay, so next class we are continuing with some more slides. I will try to complete next class differentiation. After that, we can go to the next chapter. Thank you. Any question you can ask me. If you have any question, please feel free to ask questions.